Okay. Yeah, hate my subtitles. So, should be another quicker lecture. This one is going to cover evidence for evolution. Basically, how do we know that things have evolved? How do we detect it? What do we look for? So on. So, let's get into it. So, I'm going to say so a lot. That's my transition word. Homologies are one way we can find common ancestry in species. So, these are just similar structures in species that do actually result from common ancestry. The trick is they often don't have the same function. So if we look at like the forelimbs of mammals, we all have basically the same bone structure, bone shape. There's a little bit of extension of bones, but it's all the same thing. But they're used for very different things. Whales use it for swimming, humans use it for grabbing, cats walk on all fours, bats use it for flying. So they look the same. You often need to do like X-ray analysis, things like that to actually see it because the function will be very different. We also can look for vestigial structures. These are structures that are homologous, but they don't serve any function anymore. Or if they do, it's very, very small. So like whales still have leg bones. They don't really do anything, but they just haven't lost them yet. They may lose them, they may not, doesn't really matter. Humans, our tailbone isn't really needed. Some humans are even born with tails and vestigial tails that get removed. They're just kind of like little relics of things that they don't really harm anything, but they just don't do anything either. Wisdom teeth in humans would be kind of another example. Then we get analogous structures. So analogous structures are kind of a trap. These are not examples or evidence for evolution. They are usually results of convergent evolution. So these are things where the structure kind of does look similar, especially if you don't look at the bone structure underneath. And they'll have very similar purposes, but they will not be due to common ancestry. So the example here is shark, dolphin, penguin, fish, bird, mammal, all have fins and flippers for swimming. But that doesn't mean they're super closely related. If you look at the bone structure underneath, it is quite different. This happens because of convergent evolution, which is just the idea that if you live in the similar environment or even the same environment, you may adapt to look very similar and become very similar because it is just a good body shape or trait to have in that environment. So for all of these things that spend a ton of time in the water, fins are just a good way to move in the water. So things tend to evolve fin-shaped structures to swim. But it does not mean they are closely related. A very good way to look for it is comparative embryology. So this is looking at homologies early in when we're just an embryo, when still developing. For example, pretty much everything after fish have gill slits temporarily as when they're an embryo and they have a tail. But that doesn't persist. Humans obviously don't have gills or even gill slits left over. But because we had them at one point, it means, us at some point in fish, we probably shared a common ancestor at some point. The fact that it doesn't exist in adults leads us to believe that it's probably fairly distant ancestor, but ancestor nonetheless. And then the big one, the fossil record. So the fossil record is a huge help in determining relatedness of species. It shows us species that have gone extinct. They show us when new groups appear, and they can also show us changes within groups over time. For example, we know that sharks have not really changed in the past 100, 200, 300 million years. They've basically stayed the same. Whereas other things like Homo sapiens have changed a lot in the past 100 million years. We've gone from chimps to, well, not chimps exactly, but essentially chimps to people. So this is a big way for us to actually see this. Then DNA sequencing is also available. We can actually get DNA out of fossils. We can actually get it out of soil now. It's kind of crazy. But if we directly compare DNA sequences between species, we can look for similarities. The closer the DNA sequences are, the closer related they will be. You can even do it at the amino acid level, and just it's a bit easier. You have less data to look at, but essentially the idea is the more similar your DNA, the more closely related you are. And then lastly, real world observations tell us that evolution exists. The Galapagos finches, when droughts hit, we were able to observe, wrap it up, bulldogs. We were able to observe the change in frequency and see their beaks get larger. The peppered moths, which I've talked about, we were able to literally see them change color from light color to dark and then eventually back to light. So we've observed it. It's real. There's no debating it. Evolution exists. We can see it. We have seen it all around us. So that is it for today. Some basic stuff, some things to memorize and learn. I'm going to get out of here because I've got too much to do. That's all, folks. See you later. Have fun. Be safe. Make good choices. Don't do anything I wouldn't do, but do watch this video. Wow.